There's a plant you've almost certainly never seen. It's so small that hundreds of them could fit on the period at the end of this sentence. It lives at the bottom of the ocean, and every fish you have ever eaten owes its most important fat to it. If you eat no fish and no eggs, there is a nutrient your genes rely on that your diet may be missing. Flaxseed, chia and walnuts cannot fully replace it. Today I will show you what is missing and why the most popular plant-based fix falls short, and exactly which product and dose can close the gap. I'm Dr. Lucia Aronica, lecturer in epigenetics and nutrigenomics at Stanford University, where I study epinutrition, how nutrients influence gene activity. Today we are talking about DHA. DHA is a long-chain omega-3 fat found concentrated in your brain and retina. But it's not just fat. It is an epinutrient, a compound that talks directly to your genes, influencing everything from brain signaling to inflammatory gene activity. Here's the problem. Most plant-based diets provide almost no preformed DHA. And while many people assume they can make enough from flaxseed or chia, the biology is much more complicated than that. By the end of this video, you will understand why, and you will know how to close that gap using the same molecule fish have been borrowing all along. Every cell in your body is wrapped in a membrane. In your brain, about 40% of that membrane is made from DHA. That's no accident. When DHA is available, your brain actively pulls it from the bloodstream, giving it priority over almost every other fat. Why? Because DHA doesn't just build the brain, it helps it function. Brain cells communicate through their membranes. The more flexible those membranes are, the more efficiently signals can travel. DHA helps provide that flexibility, which is one reason the brain protects its supply so carefully. But DHA does something else that's even more remarkable. It acts as a signal. Inside your cells, DHA binds to proteins called PPARs, molecules that help control which genes become more active and which become quieter. One of the effects is reduced activity of NF-kappa B, one of the body's main drivers of inflammatory gene expression. In other words, DHA doesn't simply become part of your cells, it helps determine how those cells behave. When DHA intake stays low for long periods, studies have linked it to higher inflammation, changes in brain cell membranes, and less efficient communication between brain cells. Researchers are still investigating exactly how these changes contribute to symptoms like brain fog or difficulty concentrating. But for some people, what feels like a focus problem may also be a nutrition problem. During pregnancy, the stakes become even higher. The developing brain needs a continuous supply of DHA while billions of new connections are being built. When maternal DHA status is low, researchers have observed measurable changes in the activity of genes involved in early brain development. The fetal brain doesn't wait. It builds with whatever it's given. Vegan diets provide essentially no preformed DHA, and lacto-ovo-vegetarians get, on average, only about 20 milligrams a day, a trace amount. Want to do better than the average vegetarian? Eat pasture-raised eggs regularly. A single pasture-raised egg can provide roughly 100 to 150 milligrams of DHA, 2 to 3 times more than a conventional egg. But DHA isn't the whole story. Your genes also need EPA, DHA anti-inflammatory partner. Eggs contain very little EPA, so even regular egg consumption usually falls short of providing the combination your genes need. So, if eggs aren't the complete answer, what is? Most people would say flaxseed, chia, and walnuts. And that's where things get interesting. These seeds are rich in omega-3. That's true. The catch is that not all omega-3s are the same. Flaxseed, chia, and walnuts provide ALA, alpha-linoleic acid, not DHA. ALA is an omega-3, but it's a precursor. Your body first has to convert it into EPA and then DHA through a series of enzymatic steps. Here's where things become much less efficient than the label implies. The key enzyme, called delta-6 desaturase, also processes omega-6 fats found in most vegetable oils, nuts, and seeds common in plant-based diets. It's one enzyme, 2 lines at the door, and omega-6 usually cuts in first. That leaves less opportunity for ALA to become DHA. On high omega-6 diets, researchers have measured 40 to 50% drop in the conversion of ALA to DHA. Even under favorable conditions, less than 4% of ALA becomes DHA. Add the omega-6 competition found in most modern diets and real-world conversion is often closer to 2%. To put that into perspective, 1 tablespoon of ground flax seeds provides about 1.6 grams of ALA. At a 2% conversion rate, that produces only around 30 milligrams of DHA, a fraction of what pasture-raised eggs can provide directly. And eating more doesn't solve the problem. As intake increases, the enzyme itself becomes the bottleneck, so conversion becomes progressively less efficient. You can't out-eat a rate-limiting enzyme. And there's one more complication. The enzyme we've been talking about is made from a gene called FADS2. Common variants in that gene reduce conversion efficiency even further, meaning some people make substantially less DHA than population averages suggest. None of these makes flaxseed a bad food. It's an excellent source of fiber, lignans, and other beneficial compounds. It's simply solving a different nutritional problem. So, if flaxseed isn't making your DHA, what is? Remember the tiny organism from the beginning of this video? Here's the twist. Salmon don't make DHA. Sardines don't make DHA. No fish does. Fish accumulate DHA because they eat the organisms that actually manufacture it, microalgae. Fish are simply the middleman, and the middleman is optional. Algal oil delivers the same preformed DHA directly, bypassing the conversion bottleneck entirely. Because it's grown in closed, controlled environments, it also naturally avoids the mercury and many of the persistent pollutants that accumulate in ocean fish and have to be removed during fish oil processing. This isn't just theoretical. Studies comparing algal oil with fish oil consistently show equivalent increases in blood DHA. Your cells don't know whether that DHA came from a fish or directly from the algae that fed it. But there's a catch. Most algal oils provide plenty of DHA but relatively little EPA. That's worth paying attention to because EPA complements DHA rather than replacing it, contributing to inflammation resolution through a different biological pathway. For that reason, I generally recommend choosing a product that contains both. I link several options below. None are sponsored. Some are affiliate links, so if you choose to purchase through them, I may earn a small commission at no extra cost to you. It's one simple way to support the channel and help me keep making videos like this. Rather than guessing, I recommend starting with an omega-3 index text. It measures how much EPA and DHA have actually been incorporated into your red blood cells, giving you a far better picture than simply tracking how many capsules you swallow. From there, you can personalize your intake. For most adults who don't eat fish, about 250 to 500 milligrams of combined EPA and DHA is enough to prevent deficiency. But if you are aiming for an omega-3 index of 8 to 12%, the range linked to better heart and brain health, you'll probably need closer to 1 to 2 grams a day. Pregnancy deserves special consideration. Although current recommendations suggest a minimum of about 200 milligrams of DHA per day, newer evidence indicates that women with low omega-3 status may benefit from considerably more, often approaching 1 gram daily alongside EPA. One final practical tip. If you're someone who pays close attention to supplement quality, check the TOTOX value, a measure of oxidation. Lower is better, and values below 10 are generally considered excellent. I've linked several high-quality products below. Maybe that invisible plant at the bottom of the ocean was always making what we needed before the fish, before the supplements, before anyone pointed you toward flaxseed. The molecule your brain was asking for was never in the seed, nor in the salmon. It was in the source. You now know where your genes actually source their DHA, but it's one conversation in a much longer dialogue your food has with your biology every single day. I put together a free guide, Top 5 Kitchen Hacks to Unlock Your Food's Epigenetic Superpowers. The link is in the description. And if you want to learn more about how specific foods influence your gene activity, watch this video next. Ciao!